if you do, unless it's changed, because stuff in sports science always is changing and adapting and evolving, getting better, static stretching at the start is actually not helpful. Because you're trying to stretch really a cold muscle, so you want dynamic movement to warm it up. Because you need to warm it up. Static stretching is good for after. Yeah, because you're trying to, because the worst thing you can do is stretch or force a muscle into working out that's cold. Greater chance of injury. One more question?
I have no idea.
Yeah.
I had, well, me and Abby came down here this hour, but never really did that.
Okay. Yeah. Yeah, luckily there's not going to be a test over Chapter P, this first one, mainly because there's just, essentially we're recovering most of Algebra 2, just in a nutshell. So, if you do have a specific question, we can go over it at the start, either later today, at the end of this lesson or at the start of next, if you know for sure, or remember which one you had a question on. Okay. Any questions for homework? So we're missing, okay, I think, yes, okay. Now, the first two problems we're going to do, if they miss those, that's not a big deal, because I'm hoping we don't need a big in-depth discussion on how to solve multi-step equations. Because for these here, we call them multi-step because it takes multiple steps to solve. And with any of these here, especially when the variable does not have an exponent, so x squared, x cubed, going on, we get it by itself. So 3x minus 6. Well, the first thing we need to do is add 6 to both sides. Which tells us that. So what would we do next? We divide both sides by 3, telling us x is equal to 2. And that's it. Now, if it asks us to check it, all we've got to do is plug it back in and make sure that it does indeed equal 0. So we didn't ask us to check, but if we wanted to, so we can plug 2 back in for x. And you have 3 times 2 minus 6. Well, 3 times 2 is 6, and 6 minus 6 is 0. So 0 does indeed equal to 0. And whenever we're checking or making sure that a solution works, we're just simplifying both sides individually. So if you're checking or trying to make sure something works, you're not moving across the equal sign. We can't just add stuff to both sides or do any of the other properties. Now that seems a little weird why we can't do that, but when we're checking that it's a solution, we're checking that it works. We're wanting to make sure that the 3 times 2 minus 6 is indeed equal to 0. We're checking equality, that they are equal, yes? If I start moving stuff across the equal sign from one side to the other, we're assuming that they are indeed equal. Does that make sense? So essentially for us to move stuff from here to here, we're assuming that it's equal, but we're trying to check that it's equal. You can't assume and prove at the same time. So that's just a side comment. Let's look at the next one. 5x plus 4 equals 3x minus 8. Well, we have no parentheses to simplify. It's just we need to get the x's on one side and the numbers on the other, yes? Okay. So what can we do first? Subtract 4. else are we going to need to do? Subtract 3x, because we moved the 4 from this side to here. Well, did we ever say that there was a rule that we had to do it one at a time? No. And normally we don't. And the main reason we don't is so y'all don't get confused on what's going on. Does that make sense? Now at this point, some of the short or steps that we normally would do one at a time, you don't have to. Because I feel at this point y'all are comfortable or should be comfortable enough, especially with this here. If we minus 3x from both sides and subtract 4, we're going to be perfectly fine. Because negative 8 minus 4 is negative 12 here. 4 minus 4 is 0. 5x minus 3x is 0. If that's a little too much going on at once, do it one step at a time. If you feel comfortable doing that, do it that way. Because at this point, y'all have done these so many times that we should be comfortable just doing that all at once, getting it to where we need. Now we just need to get the x by itself. So we would divide by 2. So x is equal to, that's it. Questions on this here? No, you're good. So we feel pretty comfortable with these here? Yeah. So again, there's going to be a lot of stuff in trig, stuff that where we stepped it out step by step. I will start showing you a lot of the shortcuts, the quicker ways to do this, so we're not having to do these one step at a time. Now the next thing we're looking at is rational equations, solving rational equations. We did these in Algebra 2. This was one of the last chapters we covered, solving these fractional equations. And the way we solve these rational equations, we use the least common denominator. We didn't specifically, especially once we got to solving, we didn't necessarily call it a least common denominator. We found what was in common, or what was going to make the denominators cancel out, make them go away. So our least common denominator is the term that we can multiply every term by to get these two fractions to simplify and not be fractions anymore. So we're looking for what number that we can multiply with our 3 on our x over 3 and 3x over 4 to get them to not be fractions anymore. Well, the x over 3, we would need to multiply it by, well, 3, yes? Because x over 3, if we multiply this by 3, because it would multiply with the top, which would be 3x over 3. What is 3x over 3? Because the 3 over 3 would be 1, yes? Leaving us with just x. Because that's what we want to have happen. Because if we have that, that's going to be nice. However, the 3x over 4, the 3 is not going to do that. Because if it was, that had already been done. But what would we need to multiply the 3x over 4 by? Anybody have a guess? Four, because if I multiply 3x over 4 by 4, the top would be 4 times 3x over 4. 4 divided by 4 is, they cancel out as 1, yes? Which would just leave us with. So the x over 3, we would need a 3. The 3x, over 4, we would need a 4, yes? And that's where this least common denominator comes in. It's giving us this term, this single term, that would do it for both. And the least common denominator is the first number that we can turn both 3 and 4 into. So what's the first number? Well, it would be what? 12, yes? So we can multiply the whole thing by 12 to get these fractions to reduce. And that's our least common denominator. And this here works not just with these rational equations, because it could be quadratic, it could be linear, because if we have some of the linears where it's all decimals, we can multiply by 10. I can show us an example of this here in a minute. But we can use this multiplication to make things easier to work with. So our first one is going to be 12 times x plus 3. So 12 times x over 3. Our second one, we have 12 times 3x over 4 is equal to 2 times 12. I haven't multiplied yet, mainly because it's easier to see some of the simplifies. Because our first one, we have this 12x over 3, 12 divided by 3. Well, what is 12 divided by 3? 4. And we still have our x. That's fraction reduced. We don't have a fraction anymore. Here, we have 12 over 4. 12 divided by our 4 is 3. And it's still being multiplied with our 3x. Do we have any more fractions? No, and that's the whole goal of multiplying it by 12. Could we have still solved it as fractions? Yes. Would it be more steps? Yes. And the other side is 2 times 12. Now we need to simplify. We need to multiply these. We could have, well, 3 times 3x is 9x. 2 times 12 is 24. 4x plus 9x is 13x. And lastly, we have to divide both sides by 13. $13x divided by 13 is x. $24 divided by 13, does that reduce? No. So the answer is 24 over 13. And that's it. Questions on this here? We are going to look at a few more of these here. So do we feel good with these so far? Now we could check it and make sure that it works, and this will indeed work. Now one of the nice things with the graphing calculator and the 30XS, we can use what we call the store feature. And I talked a little bit about this last year. What we can do is first get our number, 24 over, try again, 24 over 13, because that was our solution, yes? And what we're going to do is say store x. And once that's done is it's now stored that value in for x. So anytime it sees x from now on, it's going to say it's 24 over 13. Alpha y equals enter. So we had x over 3 plus 3x over 4. And it tells us that it is 2. The equation that we started off with was that was equal to 2, yes? So it worked. And the nice thing with this is if we were trying to check multiple solutions, all we got to do is change the value of x. Well, we also said that we found -3. Store x. Okay. I can come back up here. Reselected. Okay, well, that's not 2. So that's not the solution. So you can check multiple values pretty quickly and having to retype the whole thing in. But we're ready to look at the next one. (4x over 9 minus 1/3 is equal to x plus 5/3. So we need to find this least common denominator, this value that we can multiply the whole equation by and get these fractions to reduce. Because 3 will work, yes? Because 3 will reduce this 1/3. 3 will reduce the 5/3, yes? Will the 3 reduce the 9? Well, no, we would need a 9, yes? Okay. So we can multiply everything by 3 if we want. Because here the 3 and 3 would cancel. Here the 3 and 3 would cancel. But the 9 and 3, excuse me, would they cancel out? No. So we could multiply everything also by what? 9. Because in essence, that's kind of what we did with 12, right? Because we multiplied everything by 3 and everything by 4. And here, the 9 and 9 would cancel. Now, what we have left here is 4x times 3 minus, well, 1 times 9 is 9 equals x times 3 times 9 plus 5 times 9. I already went on and multiplied the 1 because, well, 1 times anything, that's nice. Here, 4x times 3 is minus 9 is equal to 3 times 9 is 27. And if we multiply it with our x, we have 27x. And lastly, 5 times 9 is 45. Now we need to get x by itself, yes? So what can we do? We can add 9 to both sides. What else can we do? Do you all feel comfortable doing these two at one, or do you want to do them one at one step at a time? We do feel comfortable with this here? Yes? Okay. I want to make sure, because if we do feel comfortable, let's do it all at once. There's no reason not to. But if this is confusing too much to keep track of, do it one step at a time. Because this here, the 9 and 9 cancel. 12x minus 27x is negative 15x. Equals the negative 27x and 27x simplify out to 0. 45 plus 9 is 54. And lastly, we would divide both sides by negative 15. Incidentally, our 54 and 15 does reduce. To negative 18/5. Questions on this here? Is some of this starting to come back? Yes? I'm going to do this problem again. Y'all can you don't have to rewrite it down. Because what I'm going to change is something dealing with what we multiply by. Does 3 and 9 have a common factor? Is there a common factor between 3 and 9? It is 3, yes? So I'm going to do this a little different. This time, I'm just going to multiply everything by 9, okay? You don't have to rewrite this out. Because our first one here, this multiplication of 9, well, the 9 and 9 would cancel, yes? Leaving us with just 4x minus. Here we would have 9 times 1 would be 9, and we have 9 over 3. Well, before we get to the rest of it, does 9 over 3 reduce? It'd just be 3, right? Here 9 times x is, and here we'd have plus, well, 9 times 5 over 3. We could multiply it, but I'm going to leave it as this here so we can see the simplification a little bit better. Now this part here, again, we have 9 over 3, which again would reduce to 3, and we still have our multiplication of 5. So by multiplying by 9, we get to this here, 4x minus 3 is equal to 9x plus 15. Any questions on this here? Because our previous part, when we got to this here, was 12x minus 9 is equal to 27x plus 45, yes? Can you all see what the difference between the two is? Well, we went, instead of having 12x, we have 4x, yes? Well, that's a factor of what? 3, isn't it? Instead of negative 3, we have negative 9. Again, factor of 3. 9x, 27x, factor of 3, 15, 45. It's an extra factor of 3. Because we multiplied originally 3 and 9. It shared that extra factor of 3. Does that make sense? So here, if it's just a number, it's not going to make a difference. It's just going to mean the numbers and or what we're solving at the end are just bigger. That's all it's going to do. If we add extra variables, we'll see here in a second, it adds solutions. And the solutions it adds will always be extraneous. They don't work in the end. So we have to take them out. So with this here, these numbers, it's not that big of a difference. It doesn't impact us as much as adding extra variables. Because here, these would cancel. Telling us that negative 5x is equal to 18. As we saw in the last one, that value simplified out. So it fixes, it's camel cricket. It's under the first desk. Funny enough, we had one of the old janitors in the past had their kids come in here and they asked if they could take it outside or just take it out of the classroom, take it outside so it'd be fine. I'm like, sure, that's fine. So they went to catch it, and one of them kind of ends up trying to catch it, stands up, it has one of its legs. And then they catch it and take it outside. I'm like, well, I think it's worse off now. But yeah. Oh yeah, that was last year. It was, yeah. Well, it was annoying, the number of crickets that were in the building that made it in. But most of the teachers can finally said that we've asked the question and heard literal crickets. All right. We're going to look at this next one here. Now, this is the first rational equation we've had that has variables in the bottom of the fractions. Now, whenever we have variables in the bottom of the fraction, the first thing we need to be checking for are restrictions. Because our restrictions are going to be any value of x that will make the denominator be 0. Because if there's a value of x that will make the denominator be 0, we have to remove it. Or not so much to remove it, but take note of it. And if it comes up as a solution, it's not going to work. Because we cannot divide by 0. Dividing by 0 doesn't work. And I think there's so many memes about it creating black holes or doing something bizarre, but it won't be one of our solutions for this here. Now, two of the places where we can see that there can be a 0 is this here, x minus 2. And the other is x plus 2. And we have x squared minus 4. Now, I didn't put x squared minus 4 up there, mainly because x squared minus 4 is indeed factorable. Now, when we need to look to see if something is factorable or if we need to factor it, is the power with x squared. If x is squared, if it has a power, there's a chance we can factor it. Most of the time when we're looking at these, we're looking at quadratics. We do have some special cases with cubics, x to the third and x to the fourth. But in this case, x squared minus 4 is indeed factorable. And normally, this is one that y'all like the most if we're going to factor, because it's a difference of perfect squares. X squared minus 4, x squared is a perfect square, it's x and x. 4 is 2 and 2. So this does indeed factor. And this factors 2, x plus 2, and x minus 2. You all remember doing perfect squares, difference of perfect squares. Okay. So, when we look at its factors, what's going to make it 0? Well, it's going to be either x plus 2 or x minus 2. We already have them listed, so we don't have to list them again. And again, for these restrictions, because now that we have this, we can now really look at our restrictions. We know that whatever value that's going to make these two be 0 cannot be a solution. So for our x minus 2, we can add 2 to both sides, telling us that if we have a solution of x is equal to positive 2, it doesn't work. Because if x is 2, it's going to make every x minus 2 on the bottoms of the fractions be 0, thus giving us a division of 0. It doesn't work. X plus 2, we would. Minus 2, because we're trying to get x by itself so we can see what is going to give us a restriction, what's going to cause us to have a denominator of 0. And that one's negative 2. So we have positive 2 or negative 2. If either one of those comes up as a solution, it tells us that it's a restriction. It doesn't work. It's not one of our solutions. So any questions on our restrictions? Okay. Now we need to use our least common denominator. We need to multiply the entire equation by these expressions to get the denominators to go away. And I like these a little better than I like numbers. Because we can almost, once we have it factored, we can look and see what we have. Because I know for sure I'm going to need to multiply everything by what? X plus 2 and x minus 2. And if you're not sure that if you need any of these more than one, start out with 1 and simplify out as we go. Because if we look at the first one, the x minus 2 cancels out with x minus 2. X plus 2 cancels out with x plus 2. And here, x plus 2 x plus 2, x minus 2, x minus 2. Do we have anything left in the bottom of the fraction? No. So do we have to multiply by anything else? No, we have enough. If you go through and you did the cancellation like we did and had something left over on bottom, okay, and then we need to add one more through. That's why I like this a little better, because we can just visually see what do we need. We're not having to worry about factoring the numbers down. Factored for us. So what we have left in the first rational expression is 1 times x plus 2, which would be is x plus 2. That one's nice. Our next one is we have 3 times x minus 2 minus 6x. Because everything else simplified out as our third rational expression with the 6x. If there had been something, another set of parentheses, we would have put it next to it. 6x times that. At this point here, we can distribute the 3. 3 times x is 3x. 3 times negative 2 is minus 6x. Now at this point here, we can't just start moving things from left to right because we still have some like terms, yes? We have 3x and negative 6x. 3x minus 6x is negative 3x. Do we have any other like terms? No. Now we can get x by itself and everything else on the other side. So what can we do? We can subtract 2 from both sides. And add 3x to both sides. Now negative 2 plus 2 is 0. X plus 3x is 4x. Negative 3x plus 3x is 0. Negative 6 minus 2 is negative 8. This is not looking good. Well, we'll see here in a second. What's our last step? Divide both sides by 4. 4x divided by 4 is x. What's negative 8 divided by 4? So our solution is x is equal to, that's one of our restrictions, yes? So, okay. We remove it. Do we have any other restrictions? Or not restrictions, other solutions. We do have another restrictions, but we are all out of solutions, yes? Because that was the only one, which means this is no solution. Well, that's kind of frustrating, isn't it? But this doesn't have a solution because the only one we could come up with is a restriction. Questions on any of this here? This is the last one we're going to do today. And then we'll pick this up to tomorrow. All right, now, just like the last one, we are going to have to find our restrictions. We're going to have to find the values of r that are going to make the denominator be 0. R minus 2, the 2 of them that we have, they are simplified. They are factored because the exponent attached to r is 1. It's not written, but it's understood to be 1. The one in the middle is r squared. So there's a chance that it factors. And again, when we factor something or factor these quadratics, the first thing we look for is the greatest common factor. There's not one. There's one big indicator that there's not one. What's the number in front of r squared? 1, yes? So that doesn't help us. And 10 does not have an r, so there is nothing in common with all three. That's kind of the giveaway. So we move on to our second step, which is our 2 sets of parentheses with 3 spaces. I think we remember this from last year, yes? Now at this point here, we would find the signs. We look at the third term. If the third term is positive, the signs are the same and match the sign of the middle term. If the third term is negative, our signs are opposite. Well, here the third term is positive, so the signs are the same and match the sign of the middle term. Minus and minus. Now we need to look at the factors of the first and third term. First term's nice, because what are our only factors that we could use for r squared? R and R. Although it looks like one of us needs a little more of that. R and R. Rest and relaxation. Yeah. Yeah, that used to be the same. You just need a little R and R, some rest and relaxation. Yeah. Sometimes we all need a little bit of R and R. All right. Now we need to look at the factors of 10. Well, the factors of 10 are what? 1 and 10 or 2 and 5. Which one do we want to try first? 2 and 5. And we can check this here, because we would do r times negative 5, which would be negative 5r. Negative 2 times r is negative 2r. And negative 5r minus 2r is indeed negative 7r, yes? So r minus 2 and r minus 5 are indeed the correct factors. Now, unless the problem decides to be a little bit meaner, the factors that show up, especially the singular factors that show up in the other denominators, are probably going to show up in the one that's factorable. Because if you notice, across all three, we have an r minus 2. They're going to most likely do that. A lot of them, if one's r minus 2, the other one might be r minus 5, so the ones that factored. It'll give you a hint, or should give you a hint. The other one should give you a hint at what the factored one should be, unless it decides to be a little bit meaner and not include either one. But then we have more factors, more to work with. It makes it a little bit harder. So, now that we have it factored, our restrictions. Well, what can't be 0? R minus 2 and R minus 5. Neither one of those can be 0, right? All right, Jessica, I'm going to put you on the spot. What value of r would make r minus 2 be 0? Okay, so r cannot be 2. London, you got the next one for r minus 5? 5. So r cannot be 2 or 5. So again, like we said with the multi-steps, doing them, moving stuff at the same time, I think at this point we could see what's going to make r minus 2 and r minus 5 be 0, yes? So if you want to write it out and work it out to make sure, there's nothing wrong with that. So we know 2 minus 2, 5 minus 5, those are both going to make 0, so those are restrictions. Now we can move on to our least common denominator, what we're going to multiply everything by to get the denominators to simplify. So what's one thing we'll multiply everything by? R minus 2. What else? What else do we need to multiply everything by? Do we need to multiply by anything else? No. Because our 1 r minus 2, so for the first one, will cancel. Our middle expression, the r minus 2, will cancel. And in the last one, the r minus 2 will cancel. And in the middle one, the r minus 5 and r minus 5 will cancel. So even though r minus 2 showed up in all three, we only need to multiply the equation by it once. Now let's see what's left. So our first expression here, so we have 1 times r minus 5, which is just r minus 5. Plus, well, everything else simplified out. It just left us with 1. Equals 6 times r minus 5. Now on the right-hand side, we can distribute the 6. 6 times r is 6r. 6 times negative 5 is negative 30. On the left-hand side, we really don't need those parentheses. So we have r minus 5 plus 1. Negative 5 plus 1 is negative 4. All right, what do we need to do? Add 4 to both sides and subtract 6r. On the right-hand side, r minus 6r is negative 5r. Negative 30 plus 4 is and then we would divide by negative 5, telling us r is equal to 26/5. Now this is a little bit different than Algebra 2. Not so much in what we did, or because for the most part we can agree that this problem as a whole, we would see it in Algebra 2. However, most likely our solution is not going to show up as 26/5. Most likely the 26 would have ended up as a 5 or 25. It would have reduced to a nice number, yes? That's one of the bigger or main differences, especially with Algebra 2 and college algebra, is the likelihood that we get a nice number is lower. Now, if we want to, we can still check this and make sure that it works by just plugging it back into the original problem. So, I'm going to borrow one of your papers so I'm not sitting here switching back and forth between the two. What we can do is plug 26/5, store x into the calculator and say 1 over x minus 2, because that's the left-hand side. Sorry. I was looking at the one above it. Plus 1 over x squared minus 7x plus 10. Now that is the left-hand side of this one here. We get 15x. The right-hand side is 6 over x minus 2. See, both sides give us the same value. Yeah. So our 26/5 is indeed the correct answer, because both sides gave us the same value.